All right, we're going to move up to Chapter 7. What's going on, my Algebra 2A students? And yes, you're still into Algebra 2A, just to make sure. I've got Acacia up here, up in here with me, and we're going to be covering this stuff. Let's see. Solve for these variables. I think that we've done this enough, so I'm not going to do the warm-up. Let's see. What is the... Oh, hey, this one is interesting. Below is the graph of f. Solve for f of x equals 0. So here's the graph of f of x over here. Can you guess what this graph is actually a graph of? I'm just curious to know. I would say that it's actually, no, it's not a piecewise actually. It's, okay, here. Why don't we just do this? Good old Desmos. Good old Desmos. Fine, not good old Desmos. Come on, old reliable Desmos. All right, here we go. I would say the graph kind of looks like 1 over x. Oh, wait. Delete. 1 divided by x. Bring it home. Whoa. What's going on? What is going on? Red graph, 1 over x. That is not what 1 over x looks like. What are you doing, Desmos? You trying to embarrass me? Give me a second. Sorry. This is supposed to be quick. Did you tell them to mask the bridges before they broke them?
Mm-hmm.
What did they say?
Okay.
Okay. All right, 1 divided by x. There we go. That's kind of the graph that we had, right?
Mm-hmm.
Here's the graph of it right there. But the thing about, and the reason why you have this 1 over x is because if you look over here, as x gets to be really big, what happens to this number overall? As your x denominator becomes really big, like how would you compare 1 over 10 to 1 over 100? I'm not 100. Yeah, 1 over 173. Which one's bigger? Would you rather have 1/10 of a pi, or would you rather have 1 over 173 of a pi?
I'd rather have 1/10 of a pie.
I'd rather have 1/10 of a pi. Right.
Sure.
So the bigger x gets, the smaller the number gets overall. In fact, the bigger x gets, the closer this number gets to 0, right?
Mm-hmm.
And you can see that in the graph. Whoop. You see that right there. Now, as you get x to be really close to 0, like for example, if x were 0.5, then 1 divided by 0.5 is actually 2. Or if x were 0.25, then 1 divided by 0.25, how many quarters does it take to make a dollar? 4. So that would be at 0.25, you would go up to 4. Or if x were 1/100th, then that's asking how many pennies are in a dollar, and then that would be x or y would be 100. So you see how it skyrockets as you get closer to this point right here. That is called a vertical asymptote. We'll be learning about those as we talk. But do you see how I looked at this graph and I said, that looks a lot like a 1 over x graph, right?
Mm-hmm.
But do you notice what we do when what does this graph, what's the difference between this graph and this graph?
It seems lower on the...
It seems lower on the graph. So it looks like they dropped it down by 1. And how would I do that? I mean, just kind of knowing what you know about k's, I would probably just go -1. Now my graph looks almost exactly like the graph. See? Actually, to be honest with you, I think I lowered it down too much. I think that this thing actually goes to 0.5.
Yeah.
I noticed that it goes to 0.5 because it crosses here at 2, comma 0. In fact, the question was asking, oh wait, let's close this. In fact, the question was asking, when does f of x equal to 0? And when does f of x equal to 0? When x equals to what? Where does this graph cross the x-axis?
2.
At 2. There we go. That's it. So the answer to that is 2. And you can use it in the graph. Yeah, these 7th grade, 6th graders are cute. They like hanging out. All right. Let's read the rest of this because I'm actually starting off with chapter 7. I might spend maybe 2 days in chapter 7. Pablo and his older sister Sienna live in a 100-foot building. Sienna loves to fly her remote control airplane off the top of the building and into the building's common pool. I don't know why you would fly a remote control airplane into your common pool, but whatever. Pablo is jealous. Oh, by the way, the height of the airplane in t seconds after its release is -2 or -22 t plus 100. Pablo is jealous since he's not old enough to join her on the roof, and so he leans out of a 20-foot window high and he throws a rock. He releases the rock at precisely the same time that Sienna releases her airplane. The height of the rock is t seconds later is given by this equation. And that equation looks a lot like the parabola equation, doesn't it? Yeah, it's the sad face parabola. In fact, I would actually venture to say that it is exactly this equation right here. Yeah. The natural question to ask is, does Pablo have any chance of hitting the airplane? All right. So that would be a good question to ask. So here's the rock. Here's the airplane. The airplane is a linear equation that starts off at 100, and it has a negative slope of -22. The parabola has a parameter of -16, which we actually know that to be actually supposed to be -32 because that actually represents gravity. We've covered this before. And the 20 over here means he started up 20 feet off the ground to begin with. So let's see. Yes, you're right. A does have a negative because it would be a sad face parabola. So I guess they skipped this and they want to return to this. All right, fine, let's do this. Problem set 7.1, and I'm not sure if I gave this to you as a homework assignment, but I will give it to you right, or I'll cover some of it right now. Cool? All right. Based on the graph below, find all of x such that f of x equals 0. Okay, here's how you do it. Oh, man, Lucas, you got it already. Yes, that's absolutely right. When x equals -2, 1, or 3, f of x will equal to 0. Basically, what I'm asking in this question is what x values give me the y value that equals to 0, or what x values are the x-intercepts? That's all I'm asking. What are the x-intercepts? And you would just tell me -2, 1, and 3. You don't need an equation to solve it. You look at a graph and bada bing, bada boom, you're done. Let's see. Solve the following equations graphically. All right? So right here, they give you the equation of the graph. And let's pretend that the graph, see this graph right here is f of x is equal to -x plus 2. Cool? And that's what that graph looks like. You can see that because the y-intercept is 2 and the slope is -1. So obviously that graph and that thing match. We're cool with that? All right. So what they're saying is, when does f of x equal to 3? So when does this graph cross negative or cross positive 3? It would be that point right there. Well, what x value is that? What x value gives you a y value of 3? -1. Cool. If you look at the graph, it's -1. Boom. Bada bing, bada boom. Hey, hey. All right. What x value gives you a y value of -1? Let's try part C. Yeah, that's all they're asking. It's actually really easy. All right, so Ethan says that a x value of 4 gives you a y value of -1. Actually, that's not true. X value of 4 gives you a y value of -2. You're a little bit off. Yeah, 3. X equals 3 gives you a y value of 3. All I'm doing occasionally just got back from drinking water, but all I'm doing right here is I'm showing them this graph right here is graphed right in front of you right there. See that line?
Mm-hmm.
You can see that because the y-intercept is 2 and the slope is -1.
Mm-hmm.
What they're doing is they're asking, when does f of x equal to 3? So all of that's saying is, what x value gives me a y value of 3?
Okay.
And in that case, this answer would be -3. You just look at the graph. Or, what x value gives me a y value of -1?
Can I use this in some scratch paper?
No, you can just look at the graph. All it is if you look at 1, 2, and 3, that goes down 1.
Oh, okay.
That's it. All right, what about this one? What is f of 4? -2. Exactly. And that's actually Ethan's answer right there. F of 4. Notice what we're doing is we're replacing the x with a 4, whereas over here in the previous one, we're replacing the whole f of x, which is actually the y, with 3.
Okay.
So I'm replacing different numbers, whether I'm putting it inside of that parentheses in the function notation, or if I'm setting the whole dang thing equal to the number.
I used to get so confused with that in the beginning.
Yeah, and so now we're unconfusing you.
There we go.
What do you think? Is that hard?
Mm-mm.
No, not bad. Not bad at all. You just look at the graph. You literally do. You can do the rest of these. Actually, here, we'll try one of these. What x values gives you a y value of 0? That would be a good question. Look at the graph.
X squared minus 1 gives you a y value of 0.
Yeah, I actually think that these are your homework. So what x values... Okay, so Lucas says -1 and +1. And if you look at a parabola, yeah, you're absolutely right. Because remember, with a parabola, it crosses the x-axis twice. So at x equals -1, your y is 0. And at x equals +1, your y is 0.
Oh, yeah.
So you would have 2 answers. Got it? Now that might change if your parabola gets shifted to the right or the left. That might be a little bit of a different answer. But for the most part, it feels like you guys can hang with this stuff really well. All right, let's try this one. Question 7. This one looks crazy. Let's look at it real quick. They gave me the graph to the right-hand side, and they said f of x, or g of x in this case, is equal to the right-hand side of the equation, and here's what the graph looks like. This is a cubic function. You can tell it's a cubic function as opposed to a parabola, which is what we're used to, because there's a 3 up there and not a 2 up there. One of the things I want you to notice about a cubic function is how many bumps does it have? Do you understand what I mean by bumps does it have?
2 of them.
It's got 2 bumps. It goes up and then bump down and then bump up, right? So it's got 2 bumps. Whereas a regular parabola, yeah, bump is my official word on that. A regular parabola has an x squared kind of thing going on, and how many bumps does it have?
1.
It's got 1 bump.
Wump. 1 bump.
1 bumpity bump. All right. What about x to the 4th power? It could potentially have 3 bumps. I want you to notice these things, all right? Because I made you take notes on talking about the end behavior of these things. But I also want you to notice the bumps. How many bumps are there? In fact, do you think there's a rule that we can make? Actually, there we go. It has 1 less bump than its exponents. That's perfect.
Oh.
I agree with you. That's actually a rule in math.
A+.
All right. So in this one, we have an x, or this blah, 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 with a cubic function is equal to f of x, or g of x. When is it equal to 5? And they're asking for an integer answer. So I put your math over there. You can start working on it right now. Mom's going to give me a call when she gets here. Make sure, is Shiloh here? Is she upstairs? Okay. I told them to bring her up here. If she's not here in 5 minutes, go down and get her. And then start working on your math out there, okay?
I was expecting it's kind of art to me.
All right, I'm sorry. My kids were asking me questions.
Can I use this as scratch paper?
Yeah, you can use it as scratch paper. But, whoa, what is that? It's really interesting because patterns between functions weren't something that I was expecting. It's kind of an art to me. Yeah, exactly. It's kind of an art. Anyway, when is the y value 5? At what x values? I'll tell you what, there's 3 of them.
Oh wow. Jeez.
Right, there's 3 possible answers.
'Cause
It would be this answer, and this answer. What does the word integer mean?
is that a number? Is that just a number? I don't
It's
know.
just a number.
Okay.
It doesn't have a decimal. So like over here, that's not an integer. Because that x value is like almost like negative 0.1 or something like that. Negative 0.15. Whereas over here, that's not an integer. Doesn't line up with that nice dotted line right there. An integer is like 1, 2, 3, 4, 5, all of that kind of stuff.
Do we
A
have
rational number is like, it includes 1, 2, 3, but it also includes 1, 1.25, 1.3786. You see what I mean?
one? Mm-hmm.
So the only integer answer is negative 2. That's the only x integer value that gives you a y value of 5. So your answer here would be negative 2. Done.
Done. Okay, that's
Done.
simple.
That's it. Check your answer algebraically by substitution. So what we can do now is we can plug in this equation, but then put in a negative 2 in there, and we'll see what happens. Can I do this on a piece of paper? Sure, I'll try it. What is 0.25 of negative 2 cubed minus 0.5 of negative 2 squared plus 2.25 times negative 2 plus 4.5. All right.
Naturally, I didn't bring.
Naturally, you would do it in your calculator. However, I feel like I've been a baller as far as like,
I'll get my calculator to see how right.
oh, I'm sorry, you're right. It's negative 2.25. I feel like I've been pretty good at getting these things correct. So let me just try it out off the top of my head. This is actually the same as 1/4 times negative 8 minus 1/2 times positive 4 minus 2.25. That would be like 4.5. So it's 4.5. And then plus 4.5. Agreed? See this negative 4.5 and the positive 4.5, those get killed. And then I really just have negative 8 divided by 4 is also known as negative 2. And then, let's see, negative 1/2 times 4 is also known as 2. Gosh, I feel like I messed up somewhere. Ooh, I screwed it up.
Once you acknowledge that you're a baller, it stops happening.
Yeah. Oh! Yeah, I got it. I figured it out. I figured out my problem. This negative 2.25 times negative 2 becomes positive 4.5, and I'm adding another 4.5. I forgot to account for that negative right there.
That's me. That's what I always
All
do.
right, so this would be negative 2, 4.5, 4.5. So 4.5 plus 4.5 is 9. So this is 9 minus 4, which is also known as 5. I'm still a baller. I got it before your calculator did.
Yeah. But I had to retrieve the calculator, so
Oh.
we don't know how much of a baller
All right.
you are.
Wait till you get to chemistry. I actually start like guessing these solutions in my head, and I thought I got pretty close. Actually, I think it was last course. Anyway, excuses. You're right. I will be quiet and stop with my excuses. I apologize. But do you see how we can check this algebraically? We can see whether or not our answer was correct. Cool? Find an integer solution to the following equation. When does y equal to 2? And what integer solution is it?
1, comma 2.
No, yeah, when x equals to 1. When x equals to 1, y will equal to 2. You can check that by plugging in 1 into here. And that we can actually do in our heads, maybe. If I put in 1 for x cubed, that's just 1. If I put in 1 for x squared, that's 1. That's 1 over there. So what is 0.25 minus 2.5, or minus 0.5 minus 2.25 plus 4.5?
Your children.
So this is 4. All right, start up on your math. Thank you. This is adorable. Start up on your math.
Yeah, she's really cute.
All right.
How old is she?
I'm telling my children to start their math. Yes, just x equals 1. She's 6 years old. All right, if I plug in 1 into here, this would be negative 4, and then this would be, this is actually just negative 2, so what is 4 minus 2? It's also known as 2. Done! Balla! I don't know if you guys got that quickly, but you realize that it's correct. I'm correct.
He's the teacher. He'll be right, most likely.
Yeah. 90% of the time I'm right, but 80% of the time I pretend that I'm wrong. How do you like that for an answer? All right.
I don't know.
How many solutions are there for x equals to 5?
3.
There are 3 solutions. Only one of those happens to be a integer solution, right? The rest of them are just, whatever.
Okay, wait. So weirdly enough, whatever, if it's like cubed, there's going to be that many solutions for each y.
Oh, that's a great question. I love your thoughts right there. Ikasia is saying, for your x cubed term, you're going to have 3 bumps. Okay?
Or 2 bumps, weirdly.
And I would say, if I gave you a y value, how many answers will you have? And Ikasia is saying there's going to be 3 answers. Like, for example, that y value gives you 3 answers.
Mm-hmm.
Right? But Sophia's actually onto something.
Yeah.
Well, I think it depends on how high and low the bumps are. Because if I ask you, when does y equal to 0 in this particular case,
What kind of...
how many answers could you give me?
No. Wait, when y equals 0?
Yeah, when y equals 0, you can only give me this
You can only
one
give
answer.
one. That's true.
Then, yeah. So, I think that my response to Ikasia would be this. If there's an x cubed term, and it depends on what y you give me, but it could potentially have up to 3 answers.
So that'd be the maximum amount of
That would be
answers.
my answer to that.
Okay.
But it could have less.
Okay.
Now, can it ever have 0 answers? That's another question I need to ask.
I think... Well,
Can you ever have like when we had a parabola, right? And the parabola went like this. And I ask you, when does the y value equal to that?
yeah, I feel like it couldn't, because it would extend on.
Yeah.
in
Yeah,
both
you're absolutely
directions.
right. Right. So like a parabola can actually have no answers.
Mm-hmm.
And that's where we got into imaginary numbers, right? But a cubic function will never have no answers.
Oh yeah, because they exceed past the...
Because these ones will
curves.
keep on going up forever.
Yeah, versus...
So no matter what y value you give me, it will always give me something.
Cool. That's
Whereas to the 5th power, x to the 5th power, looks something like this. How many bumps?
4.
Potentially how many answers?
Potentially 5.
Potentially 5 answers. Can it ever have a y value where it only gives me 1 answer?
Yeah.
Sure. I make the y value up here. Can I ever have a y value where it gives me 3 answers?
Mm.
Well, what about if I choose my y value right here, and then it's like right over here? That point,
Okay, then,
that
yeah.
point, and that point.
Yeah, because the bumps don't always have to be at the same they're not always going to have
Yeah,
the same.
the bumps can be different.
Okay.
It depends on what numbers you choose. Will it ever have no answers?
Mm-mm.
No. In fact, we talked about the end behavior of x to the odd power. I think some of you came up with rules for that. And since they end in opposite directions, it will never have no answers.
That's weird.
Does that make sense?
Yeah.
All right. One last thing is I can think of a way that I can make this only have two answers. Can you think of that? It's a little it's not really a trick. You just kind of got to think about it.
Would you have to give us... Oh, no.
I'll show you. You ready? Here's a way that I can think of where it only has two answers. Here's one answer. Let's look at x-intercepts. Here's another answer. That's only two answers.
Oh, so if it's the x-intercepts, it'll only have... Well, would that be dependent on the shape of the graph? Because what if the curves all go through the x-axis?
Wait. Oh, look at the bump at the top. What about the bump on the top? What are you talking about?
I think she means whoever said it, right here and right here.
The curve on the right? Well, I mean, I could figure out a parabola that will have that property.
So is it possible to have all of the curves go through the x-axis? Because then...
Is it possible to have all the curves go? Yeah, you could have a parabola that looks like this. 1, 2, 3, 4, 5.
So does that mean that to have two, a point that only goes... Wait. So would the graph have to be that type of shape in order for it to only have two?
Yeah. I mean, you can just kind of...
That'd just be an instance where
it
could happen. Okay.
Yeah. But I think that maybe the story that we're... See, like, look. In geometry, the way that we teach you geometry, and I actually didn't like the way that I was taught geometry, is we learn a whole bunch of rules, right? It is like axial 5.731 theorem, whatever, paragraph 2,
remember everything.
whatever, line stuff, Penal Code 8 or something like that. It was dumb. I hated it.
100% agree.
And instead of me actually telling you all of the rules, I want to sit down and come up with them. Because I feel like when we discuss the rules and we argue about them and go back and forth and debate them, that you learn them better.
Yeah, because there's like a lot of logic in math, and so if people come up with it based on what they're logically seeing,
yeah,
that would make sense.
All right, let's say the top of the y-axis in the example is at 10. Y equals 10. Yeah, all right. I think that what they're saying is the two bumps, like over here, let's say it goes way up here or something like that. Hey, that's where it crosses only twice.
Mm-hmm. That's understandable.
All right.
That'd be like if you were to draw another imaginary x-axis.
So that's a part of math. So an observation that we've made so far is whatever the power of the exponent is, how many bumps will it have?
One less than what the exponent.
Or it could have one less than the exponents, right? Because if you actually graph x to the fourth power, the graph looks like this, believe it or not.
Really? Weird. That's so strange.
Well,
To get more familiar with these.
it's because, I'll tell you the reason why, is it's because you didn't add any extra terms.
That are going to make it go all.
That kind of give it that extra stuff. You know what I mean? It's almost like those bumps, which the x to the fourth power looks kind of like a W. It's almost like those bumps got so close to each other that you can't see them, but they're still there.
Oh, okay.
Does that make sense?
Mm-hmm.
I think that what it happens is when you just have regular x to the fourth power, those bumps kind of converge on each other.
They're so close.
They're so close that they just look like it. See, like, look. We'll go down to Desmos, and we'll graph x squared.
If Desmos wants to be a friend, not a foe.
And then we'll also graph x cubed. Or no, x to the fourth power. And you can see it still looks like a parabola. It's just kind of more squarish.
Mm-hmm.
But if I start messing with this thing and I add more terms, like I can do with stuff, it's like 3x, or let's go 3x squared, 3x cubed minus 2x squared. Let's make it minus, let's make it minus 5x. I'll make this number smaller, and then we'll also make plus 7, something like that. And I zoom out. Like, look, this is still my x to the 4th power. It's just messed with.
I have a weird question. Is there someone... Okay, if you were to just graph, or if this was your equation you said for your parabola, would that be the equation for one of those curves?
If, what?
Like, say you made another equation and you put negative 5x squared plus 7, would that parabola be on top of one of these curves? And, like, essentially be the... No.
Negative 5x squared plus 7.
Oh, it wouldn't, duh, because A. Okay.
No, you just have 3 different graphs.
Oh, okay.
But I think, Acacia, I think that maybe you're onto something, because I actually feel like this might be coming up, and I'm just letting you know. One thing that we could do is ask a question like, when do these two graphs meet?
Mm-hmm.
In fact, that's actually kind of what we did in that one problem with Sienna and her brother, Jose or something like that, Julio, is she was like negative 22x plus 100, whereas his rock went at like negative 16x squared. I think it was plus 5x or something. What was it? Let's go back to it. Oh. 50x plus 20. 50x plus 20. And then what I want to do is I want to maybe make this graph a little bit, I'm going to look at it a little bit differently. I want to go from 0 to 100.
I did not know you could do that on...
Yeah, Desmos can do some pretty awesome stuff, and I wanted to go from negative 1 to 10. It's just easier to see that way. Oh, no, backwards. I want to go from 0 to 10, and I want to go from negative 1 to 100. There we go. So, like, look. Here's his rock, and here's her airplane. And the question is, when do they cross? Well, they cross at 2 points.
Mm-hmm.
So I guess the other question is, will they ever hit? That's actually kind of a physics thing, to be honest.
Does that have to do with the... Whatever, I don't even know how to... this stuff.
And you guys want to know something about physics, which maybe you don't want to know anything about physics, and don't worry, I won't teach you anything about physics. Well, at least I won't teach anything about physics without you, and tell you that I did.
His secret.
Yeah, that would just be my secret. I'm slipping in there. But
she's saying something about a toothbrush.
One of these things that we're doing in physics is we actually apply all of this math that I'm teaching you to the real world. So all of this stuff applies to the real world. Anyway, let's go back to this one. How many other solutions are there where y equals 5 and the answer is 3 other times? And approximate the solutions to this one. Well, we know that one is negative 2. That's good, right? The other one is, I don't know, you would have to guess it. And I would say negative 0.2. Negative 0.25. You want to go with that? That's fine by me. And then also this would be maybe 4.25. And how could you check this? What could you do?
You could put those into the equation, substitute those answers.
Well, you could plug it into Desmos, but I think it would be good too is if you actually just put in negative 0.25 into this equation and figure it out. You know, your calculator will do it for you, and then your number should get close to 5. So maybe try negative 0.25, and then also try negative 2, and see which one got you closer, and then that would be my answer.
Okay.
You see, this is actually a good way to do math, is you graph it out and then you kind of approximate it and get closer and
Use
closer and
process
closer.
of elimination. Figure
Yeah.
out which one's closer.
Depending on how accurate you want to get. This is the way math is done. All right. I'm pretty sure that this, actually, you know what? This X pass is not on your thing. So we'll move on to the next section. I'll be honest with you, I think I did homework 1 for you. I don't even remember what I assigned homework for. Anyway, let's do this one. Okay, here. This one looks crazy. Let's try this. Use the graph on the following page to solve these answers. Check your answer symbolically, not by solving it algebraically, but simply by plugging in your solutions. All right. So number 2 looks horrible. All right. What can you tell me about number 2? What can you tell me about the left-hand side of the equation?
It'll be equivalent to the right-hand side.
Well, it's equal to the right-hand side, but really, this is like saying f of x is this, okay? And g of x is equal to this. And what I'm asking you is, when does f of x equal to g of x? When are they at the same? When do they equal each other? At what x values? This is where I taught you this with lines. When I said something like,
Is it 1?
do you guys remember the lines when we did f of x is equal to 3x plus 4 and g of x is equal to negative 2x minus 5? And then I said, well, when does f of x equal to g of x?
Yeah.
And you guys had to solve
Yeah.
equations? That's the one where I'm basically asking you, when do these two lines cross?
Mm-hmm.
At what points does the x values equal to the y value?
Are we able to answer that without solving?
Well, actually, yes, you're able to answer this without solving, and I'll tell you how, is they actually told us how to do it. They said, use the graph. So let's look at the graph. All right. Before I use the graph, though, let me mess with this a little bit, if that's all right with you. Because you're going to realize, hey, wait a second, this is actually really easy. All right, you ready? X cubed plus 4, or plus x squared minus 4 equals x cubed plus x plus 2. If it's right with you, can I move everything over to the left-hand side?
Mm-hmm.
All right. So to do that, I would subtract x cubed, I would subtract x, and I would subtract 2. That would just move everything over to the left-hand side. So this is x cubed minus x cubed, also known as 0. I don't need to write it at all. I've got an x squared over here, and it's not subtracting any x squareds over here, so I'm not going to mess with that. Minus x minus 6 equals to 0. All I did was I moved everything over to the left-hand side. Are you confused by anything? You understand where I got the minus 6?
Mm-hmm.
Okay, all right, just making sure. So really what I'm looking for is my answer is, when does this parabola equal to 0? X squared minus x minus 6. All right, fine. Let's go down. Do I have a parabola where they gave me x squared minus... Oh, there we go. X squared minus x minus 6 is at...
Oh.
When does that equal to 0?
At 3 and at negative 2.
At 3 and negative 2. So that's it. That's your answers. Here, I'll show you. I know, you guys are like, wait, it's that easy? Yeah, it's that easy. Let's go to
No,
Desmos.
yeah, when it's that easy, you feel like you did something wrong. Because there's no way.
Well, let's double check it. How's that?
Yeah, that's always fun.
All right. So let's go to home to get me on the right side of the graph. I'm going to graph one of them, x cubed plus x squared minus 4. And on the other graph, I'm going to graph x cubed plus x plus 2. And I'm going to ask myself, well, when does this thing cross each other? Because here's one graph, and
Oh
here's the
yeah,
other
it
graph.
definitely looks like we're correct.
One is at x equals to negative 2. And the other is at x is equal to way up here. 3.
Wow. Wow. That's weirdly easy.
I typed it in wrong. What do you mean I typed it in wrong? It's correct. Oh, no. Think of this as one equation, and think of this as another equation, and you're asking when do those equations equal to each other? So what I did was I graphed one equation, and I graphed the other equation, and then I said, when do they cross each other? I simplified this originally by moving everything over to the left-hand side, and then graphing it, and then graphing it. But to be honest with you, I didn't need to even graph it. I mean, if I asked you to solve that problem for me, you guys would be able to know how to do that. And how would you do that? But how did you know that moving everything to one side would give you the points where they cross? Well, first of all, you would know how to do this because this is simply a quadratic equation. Negative boy plus or minus the unsure radical party due to a square minus 4 awesome chicks all over 2 a.m. That's a quadratic equation. Or you could just factor this as x minus 3 plus 2. Yeah, that's right. Sophia's asking me, well, how did I know that moving everything over to the left-hand side would tell me exactly what?
I'm done with math.
All right, do another day of math because that's all I have ready for you guys.
Can I have a toothpaste? I want to brush my teeth.
I didn't deny my daughter any time to brush her teeth. It's fine. But do your homework. Oh, no, you already made this one all 30. Use this one. Here. All right. Sophia was asking me, how do I know that that's where the points in the graph intersect? Well, my answer to that is this. All right, let's try another one. 3x to the 4th power minus x cubed minus x squared equals 2x to the 4th power minus x cubed plus 2x squared plus 4. All right, my answer to that, to your question, Sophia, is
it because it's a combination of the two of them?
You don't see how that helps. Well, I'm not really changing anything I'm not really changing anything mathematically when I move things over. I didn't change the equation. The equation's still the same.
It's just a smaller version.
It just
of it.
looks a little bit different.
More simple.
It's almost like the equation is the same person. It's just wearing different clothes.
Is it just like simplifying it? Is that like a way to simplify it?
I'm just simplifying it.
Yeah, so that makes it easier to solve.
You know what I mean? It's almost like the graph of 3x cubed plus 2x squared plus 3x squared plus 4 is equal to f of x is going to be the same as the graph as 3x cubed plus 5x squared plus 4 equals to f of x. Because the x squareds and the x squareds can combine to make the, something. You're exactly right. All I'm doing is just simplifying it a little bit. I'm not mathematically changing anything.
Mm-hmm.
I'm just moving things over to the left or moving things over to the right, but I'm doing it so it's all fair.
Mm-hmm.
I'm subtracting 2x to the 4th power from both sides. I'm adding x cubed to both sides. I'm subtracting 2x squared from both sides. I'm minusing 4 from both sides. So I'm mathematically doing something correct, and so it's going to give me some kind of crazy thing equal to 0, and then I basically look at that graph and I say, well, when does that crazy thing, which I'm assuming it's going to be that one. Yeah, it's got to be that one. When does that equal to 0? The answer is going to be at negative 2 and 2, which you can go back and check. And that would be a good thing for you to do. Go back and check. Put in 2 over here and see what the left-hand side is equal to. And then put in 2 over here and see what the right-hand side is equal to. If it works, it works. You know what I mean? So the point of this is to find where each of the graphs equals to 0? No.
It's just that when
Actually-
you simplify it, since you got rid of everything on one side, that side would essentially equal 0.
Yeah. Essentially, yeah. Here, let's do this problem. This problem right here. Got it? If I move everything over to the left-hand side, this would be x to the 4th power plus 0x cubed minus 3x squared. Let's say I didn't move the 4 over. Okay? Let's say I didn't move the 4 over. The graph that they gave me was this. But let's say I didn't do that. Let's say I didn't set it equal to 0. Say I set it equal to 4. Then let's go back to Desmos right here. And we'll graph, what are we graphing? x4 negative 3x squared. All right. X to the 4th power minus 3x squared. So I guess the question that I ask is, instead of saying when does this equal to 0, when does this equal to 4? Right? Because I didn't finish putting everything over to one side. I said, when does this equal to 4? Well, it does. Look. Right here at negative 2 comma 4 and also at positive 2 comma 4. So the reason why I didn't, I didn't need to move everything over to one side. I could have left that 4 on the other side. I just happened to move the 4 over to the other side because they gave me the graph for it when the 4 was on the other side. So at that point, you can think of your x-intercepts as negative 2 and positive 2. They all gave me the same answer. Yeah, they all gave me the same answer. Because it's the same equation. You're just making the right-hand side of the equation equal to something different. Yeah. I know this is kind of an advanced topic, and I'm glad that we're having this conversation. We're kind of discussing these things. All right, how are we feeling about this? I mean, it's not hard at all. I don't think it's hard. You can tell me if it's hard or not. But it's important. All right, let's do this. I might be able to cover chapter 7 all of today. Let me see. Let me just take a look real quick at something. I'm just wondering, how fast am I asking you guys to go? So we covered 7.1 and 7.2. I did have a tough time with the fractions at first, though. Remember that? I'm not sure. I don't remember what fractions you're talking about. Are you talking about the fractions for the a value? Huh. 7.3. Okay, let's see, 27. All right, I'll tell you what. Oh, 1/2 plus 3/4. Yeah, okay, fine. Oh, okay, yeah. Here's what my thoughts are. I finished lecturing on function 7.1 and also 7.2. I could finish 7.3 today on Wednesday and just get ahead. Or I could stop now and say, why don't we just stop and we'll start up chemistry in like half an hour, and I'll cover 7.3 on Monday next week. It sounds like that's what you guys want to do. All right, I'm fine with that. You're welcome. We are going to stop. I'm not going to cover any more Chapter 7 with you. I'll cover the rest of 7 with you on Monday, next week. And so far I talked about 7.1 and 7.2, which I feel like you folks have been flying through, so it hasn't been that bad. All right. All right. Then I'll talk to you later. Yeah, why don't we start chem class at 2:15? And I don't imagine I'm going to go through a whole lot on that side either. I'm far enough ahead in my algebra class that I feel like I could stop and not be completely in trouble. But please keep in mind that I have to keep up a certain schedule. Although Bradley sounds like he wants to be out of here, so I'm fine with that too. All right, I'll talk to you guys later. Have a wonderful day.